The next important concept is to look at random walk and moving averages. So these are other ways to explore the effect of time series data. Now, a random walk is a stochastic, which is also known as probabilistic, process that measures each successive data point as a random step. Consider a person who walks in one direction, one step, then takes two steps and makes a right turn, then takes one step, making another right turn. And if the person did this over and over again, the path would appear to be random as they walk that path. Financial analysis uses random processes extensively, and that's what we're looking for. We're looking to get to this random process. Moving averages are a very simple concept. They calculate the average for a given number of observations, say 3, and then keep computing a 3-period average for each new data point. And so we see a lot of concepts of 3-day, 7-day, 21-day, and 30-day moving averages. Now, in the random walk piece, in many instances, we use this random walk to help inform us of certain processes. So while the direct observational data points may not be truly random, some aspects of the observation may be. For example, while the stock price may not be random, the difference between the days may be random. So you can see here by these two charts. On the left, we have maybe some sort of pattern for the NASDAQ where it's going up and down and there might be a slight trend. Although we saw from the previous slides and previous modules that the regression equation for this did not work so well and maybe there's a problem with this trend. But we'll assume that there's a trend for this example anyway. On the right side, what we've done is we've created a difference between each day. And you could see that if we draw that trend line, which is that red dotted line against the orange data points, you could see that it's clearly flat. And so there is no trend at all. So we can develop an equation for the random walk, which is comprised of 3 components. So y of t is equal to y of t minus 1 plus the average of the difference plus some error term. So yt is the value at time t, yt minus 1 is the value from time t1. The mu d is the mean of the differences with an error for each observation. What we then have is a series of this form with random differences. You can see that mu d determines the trends. The value of mu d, if it's greater than 0, will have an upward trend, and if it's negative, it will have a downward trend. So what is this saying? This says that if your differences, if it seems to be positive, if your differences tend to be positive, then that means you're going to have your upward trend. And if your differences are negative, you'll have a downward trend. So prediction can be made using a formula yt plus 1 is equal to yt, which is the day before, plus the difference, where yd is the estimated average difference denoted from the first equation, mu d plus some error term. Now, the moving average is a very simple concept because we're just taking the average over a number of periods. So we can calculate a running 3-day moving average, which calculates the average of the current period and previous 2 periods, 7-day moving average, which is a sample calculation for 7 days, and the number of periods required is specific to each case. So in some cases, based on activity, you may focus on a 3-day moving average, 5-day, 7-day, 21, or 30-day, and it will provide an estimate based on what the analyst is looking for. So below, we can see from the same set of data what a 3-day moving average and a 7-day moving average looks like. So you can see how the 3-day moving average definitely smooths out the line a little bit. The 7-day average does it a little bit more. And you can then use that 7-day average or 3-day moving average in other analysis, which is usually how the moving averages will work.